Assalamu alaikum and good morning to one and all. Today we'll study about bioassay of acetylcholine using rat ileum by 4-point bioassay. I am Sheikh Abu Sufyan. Welcome you to my YouTube channel Pharma Learning Forever. At the end of this e-learning session, you are able to discuss requirement and procedure of this experiment, learn objective of experiment, explain receptor binding of acetylcholine in GIT, and draw DRC of acetylcholine and calculate unknown concentration by 4-point method. So let's start with the objective of this experiment. So objective of this experiment is to determine unknown concentration of acetylcholine by 4-point bioassay. So drug we are using, it is acetylcholine, and method that we are using, it is new, that is 4-point bioassay method for determining its unknown concentration. So let's start with experimental condition and the requirement of the experiment. So to perform this experiment, we need instrument and the requirement like student's organ bath with thermostat it is needed, because we need to maintain temperature at 37 degrees Celsius plus minus 2. We need aeration tube so that we can provide oxygen to the tissue. So aeration tube, it is very important requirement. Tuberculin syringe is needed to inject the drug as per appropriate amount. Then Petri plate, beaker and pipette, these are also needed to process the tissue and to mount it on the organ bath. So this is about the instrument and the requirement. Let's see which animal tissue we are using. So perform this experiment, we are using rat ileum because the rat ileum contain more amount of the cholinergic receptor. Since it contain more number of cholinergic receptor, so acetylcholine can give very good response with the rat ileum. So rat ileum, it is more sensitive to the response of the acetylcholine and it give wonderful contraction. So that is the reason why we have selected rat ileum preparation. The drug we are using, it is acetylcholine standard. We need 10 microgram per ml and test solution it is needed. So the standard concentration it is known, that is 10 microgram per ml, whereas test solution the concentration it is not known, and that we are going to determine by using 4-point bioassay. Physiological solution, obviously we are using thyroid solution because we are using GIT preparation. So all kind of GIT preparation or tissue if we are using, so physiological salt solution which is required to keep that tissue alive, it is a thyroid solution. So we have seen even in case of the fundus, the rat fundus strip, or then in case of the rat ileum we are using thyroid solution. Okay. Contact time, it is 60 seconds, so it is fast contracting tissue, but it is not as fast as the fundus strip. So we are using 60 seconds as the contact time in case of the rat ileum. Even you can use 30 seconds. So some of the investigator, they use 30 seconds as the contact time. At 30 seconds also it gives very good responses. Okay. So this is all about experimental condition, and lastly 37 degrees Celsius plus minus 2, that I have already mentioned, that we maintain we will maintain this temperature so that the body temperature can be maintained and the tissue can remains alive. So that I have already mentioned, that is the reason why we are using the student's organ bath with the thermostat. Okay. So this is all about experimental condition and the requirement that we need to keep constant throughout the experiment. Now let's see about the receptor binding of acetylcholine and principle of 4-point bioassay. So the acetylcholine, it basically bind to two type of receptor. One, it is muscarinic receptor, and second one, it is the nicotinic receptor. So since the acetylcholine binding to this receptor, so it will bind generally to the cholinergic receptor. They are also called as parasympathomimetic receptor. Since two type of parasympathomimetic or cholinergic receptor are present, that is muscarinic, so you call those receptor as the M type, and second one, it is the nicotinic, and you call those receptor as the N type receptor. These nicotinic receptor are present especially in case of the skeletal muscle. Okay, so nicotinic receptor, they are present in a skeletal muscle, whereas your muscarinic receptor, they are present in the GI tract. So in case of the cock ileum or in case of the rat ileum, the receptor present, those are the muscarinic in nature. So GIT system muscarinic receptor are present, And since you are using a GIT tissue, that is the rat ileum, so you are going to study the effect of acetylcholine on muscarinic cholinergic receptor. So here the receptor that you are going to study, it is a muscarinic cholinergic receptor. Let's see what is the principle of this experiment. So in this experiment, what you are doing, you are comparing the potency of the standard acetylcholine. So acetylcholine potency, it is determined by comparing its activity with that of the standard solution of the acetylcholine by using 4-point bioassay. So simply first we are taking the DRC of the standard, then we are taking the DRC of the test, so that you can have the good comparison between the potency of the standard and the test. And based on that, you are selecting the method, that is 4-point bioassay. So we'll see the procedural part in the later slide, where we'll see how we perform this bioassay and how we compare the potency of the standard and potency of the test, and based on formula how we will calculate unknown concentration of the test acetylcholine solution. So this is the principle. So where you are comparing the potency of the standard acetylcholine with the potency of your test acetylcholine solution, and in relation to that you have used the formula and calculate unknown concentration. Let's see what is the advantage of this bioassay. So right, we have studied different bioassays. So we have studied matching bioassay, we have studied interpolation bioassay, then we have studied the 3-point bioassay, and now we are studying the 4-point bioassay. So in case of 4-point bioassay, it has the precision and reliability even better than 3-point bioassay. So we have seen in case of last session that 3-point bioassay, it gives you a more accurate result, right? And it helps you to minimize the error. So in case of 4-point bioassay, it is much more better as compared to 3-point bioassay in terms of their precisions and the reliability. Means it give more accurate result, and it help you to reduce the error even much better as compared to the 3-point bioassay. So this is the advantage of 4-point bioassay over 3-point bioassay and other type of methods that we use to calculate unknown concentration of the drug. Let's see what is the disadvantage. So obviously, since instead of 3-point, here you have used the 4-point, so it need large amount of the sample, even more than 3-point bioassay. And also you are going to repeat, instead of 3 sequence, you are going to repeat the 4 set of the reading. Since you are repeating the 4 set of reading in 4-point bioassay, it is the much more time consuming and tedious even as compared to 3-point bioassay. Okay, so the advantage is that the precision and reliability, it is the better. Disadvantage is that it need large amount of sample, and it is the very much time consuming and the tedious method. So this is about the receptor binding of acetylcholine, its principle and advantage and disadvantage of the 4-point bioassay. So let's see about the procedure of this experiment. So as a part of the procedure, the first thing that you need to do, it is you need to sacrifice the rat by spinal cord dislocation. So where you have to put your thumb on the head of the rat and you have to stretch the tail so that that animal can sacrifice, or that animal can be killed without pain. So it is the one of the painless, it is one of the method of the painless killing of the animal. So what you say, you are not mentioning the killing, but you use appropriate word, that is you are sacrificing the rat by spinal cord dislocation. Once the rat it is sacrificed, you are going to open its abdominal cavity and you are going to isolate the rat ileum. Now where is rat ileum? Which portion of the GIT is called as the rat ileum? So try to remember. Suppose if this is the stomach portion of the rat, okay, and obviously from the stomach, the small intestine it is going to start. So the initial part of the small intestine, which is the point of contact in between the your stomach and the small intestine, so that portion it is called as the duodenum. Okay, so I'm just writing the D here because you already know the properly what do you mean by duodenum, and you already studied the anatomy. So the initial portion it is called as the duodenum. Then there is the intermediate portion which is present in the small intestine. So that intermediate portion it is generally called as the jejunum. So I am writing jejunum as the J. And then after jejunum, that you can easily identify if you can isolate the tissue. Okay, so there is a last portion that is connecting with the that is connecting with the large intestine. Okay, so the intermediate portion is called as the jejunum, and the last portion or the lowest portion of the small intestine, that is called as a ileum. Okay, so the ileum, it is a portion which is specially connecting to the large intestine. So after ileum there is ileocecal junction is there, and after that the large intestine will start. So the ileum, you must remember that the ileum, it is the lowest portion of the small intestine. So you must know the location. So it is the lowest or the last portion of the small intestine which connect your small intestine to the large intestine. So that portion the isolates you can give cut here after the jejunum and before your ileocecal junction or the point that is connecting with the large intestine, and then you can make the number of the strip out of that, and those strip can be utilized to perform this particular experiment. So location must be remembered, it is the lowest or the last portion of the small intestine. Okay, so that is that is the ileum. So that you can isolate and you can kept in the thyroid solution so that you can complete its preparation. You can put the thread, so that thread can be also be applied on the aeration tube, and second thread, that is the last thread, can be applied on your the lever. Okay, so now we'll see the time cycle of the acetylcholine bioassay, and let's see what are the different parameters. So obviously first thing is the baseline, so that we are taking for the 30 second. So I'm repeating this for every experiment so that you must remember it and no one should forget this basic thing, because this we have to maintain constant throughout the experiment. If you are not keeping this constant, then you may not get proper result of the experiment. So baseline that you are taking without taking the drug, so generally you get the plain baseline, okay, because you have not added any drug, so you are not getting the contraction. So for 30 second you can measure the baseline. Then contact time you are using, it is the 60 second in case of the right ileum as a tissue and the acetylcholine as the drug. So when you take the baseline, after that you are injecting the drug with the different doses of the drug, and that drug you are keeping in contact with the tissue for the 60 second. So since you have administered the drug, so after administration of the drug you will get certain set of the contraction and the liver will go up. Okay, so this liver, it is going up after administration of the drug. So you are keeping that drug in contact with the tissue for the 60 second, and once that is over, then you are giving the washing so that the drug can be removed from the site of administration, or drug can be removed from the receptor binding site. So when you give the washing and when drug it get removed, and you are also putting that extra load down, so due to that load and due to the washing, the tissue will start relaxing, because drug it is not now washed out from the receptor binding site, and contraction that you got, it is due to the drug. Okay, so when you give first washing, you will get response something like this, second washing, and then you will be giving the three washing. So you are giving three washing each of the 60 second. So you are spending total 3 minutes in the washing period, and when you are taking next response, again you are taking the baseline, and there you are giving the second dose, and you are taking the response, and you are giving the washing, okay, for the 3 minutes. So there are three washing, each washing it is for the 1 minute. Okay, so total time cycle that you spend in case of acetylcholine bioassay, it is 270 second or it is 4.5 minute. So the 4.5 minute, it is total time cycle for taking one response, that is 30 second of baseline, then 90 your 60 second of the contact time, then you are giving the 3 minute you spent in the washing, that is three washing, each it is of the 1 minute. So total time cycle you have spent, okay, till this point it is of 4.5 minutes. So this is about the time cycle of acetylcholine bioassay. Let's move on to the next procedure. So the procedure, it is almost same as other bioassay that we have seen. So you have to mount the tissue on the tissue organ bath with the thyroid solution. So this is the tissue organ bath. So here you are going to mount that particular tissue. Then you are going to apply one thread from this side. It is on the aeration tube, okay, and the second thread you are going to apply it on the lever. So second thread it is tied on the lever, so that whenever it is the contraction, this lever can be pulled and you will get this type of response. Okay, so this is how you are measuring the response, by using the lever, and here you are putting the sketch pen tip so that your responses can be recorded. So you have to mount the tissue on the tissue organ bath with the thyroid solution, and after relaxation of the tissue you can record DRC of the standard not as serotonin, you just correct it. It is basically the acetylcholine solution. Okay, so you are taking the DRC of your standard acetylcholine solution, and then you are taking the DRC of your test ACH solution. Okay, so DRC of the standard and DRC of the test acetyl solution you are going to take, and then you are selecting two doses of the standard and the two doses of the test. Okay, so that is the T1 and T2. Okay, so after mounting the tissue, after relaxation of the tissue, you need to record DRC of standard acetylcholine and test acetylcholine solution. Once that is done, then you here, since it is 4-point bioassay. So since it is 4-point bioassay, you are going to select the two doses of the standard. That is S1 and S2 in the ratio of 1:2, and two doses of the test, that is T1 and T2, that should fall between two standard, that is S1 and S2. So this will see when we draw the DRC. So there your concept become more clear, how you are going to select the two doses of the standard and how you are going to select two doses of the test. Okay, so this is about the selection of the drug, and then you are going to repeat the doses of the two standard and two test randomly in the sequence using Latin square method. So let's see how we are using Latin square method in this case. Since it is 4-point bioassay, so now you can see there are total 4 doses, 2 of the standard and 2 of the test. So this is one thing, that is you have selected 4 doses. Second important thing is that you are repeating these sequences with the 4 set. For example, in set 1 you have followed the sequence of S1, S2 and T1 and T2. In set 2 you need to follow the sequence of S1, T1, S2, T2. Okay, so now you can see the sequence that you have followed in the set 1, it is not repeated in the set 2. Then in set 3 you are going to follow the sequence of T1, S2, T2 and the S1. Okay, and then set 4 you are going to give the dose with the sequence of T2, S1, T1 and S2. So what we did here, we have selected 4 doses, 2 of the standard and 2 of the test, and each set that we have repeated for 4 times by changing the sequence, and that sequence it is not repeated earlier. So this method of randomly selecting the different sequence of the test dose, okay, and that is repeated for depending upon the number of doses. Like if in case of 3 points, since there are 3 doses, so we have taken 3 sets. Here there are 4 doses, so we are taking the total number of 4 sets. So this method it is called as Latin square method. So by Latin square method you are randomizing the dose sequence so that there is no bias. You are reducing the error, okay, and you are trying to get more accurate result. Okay, so now selection of the dose is done. Now let's see how to take the DRC of acetylcholine and how to perform 4-point bioassay. So as usual, as a regular procedure, what we are going to do, first we are taking the two responses of the 0.1 ml and 0.1 ml of the standard, and once we ensure that these doses are giving the same response, like at the same dose when it is giving the same response height, then it is called as a equipotency. So once you ensure the equipotency, now you can give the next higher dose, that is 0.2 ml. Then once 0.2 ml give good gradation between 0.1 and 0.2, you can go ahead with the next dose, that is 0.4 ml, and then you can give the next dose, that is 0.8 ml. Now you can see in this experiment, since we have to already take many numbers of reading, so we are not going till the submax and we are not going till we get the ceiling effect. So in case of standard and test, minimum number of responses we are taking are the 4. So we are taking 4 responses in case of the standard. So now we have done with the 0.1, 0.2, 0.4 and 0.8. So the 4 responses of standards are done. So this is called as DRC of the standard acetylcholine. So okay, so we have seen till the standard. So it is called as the DRC of the standard acetylcholine solution. So we have taken here 4 doses of the standard, 0.1, 0.2, 0.4 and 0.8. Now second step, it is we have to repeat the DRC of the test. So now from here we are going to start the DRC of the test. Obviously we have to start from 0.1 ml. So 0.1 ml dose we have given. Then we are going to give the dose of the 0.2 ml. of the test, then 0.4 ml of the test we have given and it gives some response, and then we have added 4 dose, that is 0.8 ml of the test. So now once this is over, you have taken the responses till 0.8 ml of the test. Now this graph that you got, it is called as the DRC of the test acetylcholine solution. Okay. So till this point it is the DRC of your standard acetylcholine solution, and from here onward there is the DRC of the test acetylcholine solution. Now we are done with the first two steps, that is taking DRC of the standard acetylcholine and DRC of the test acetylcholine solution. Now third stage, it is selection of the test and standard dose. Now let's see how to select test and the standard dose. So first we'll see about how to select the S1 and the S2. So in case of S1 and S2, the criteria for selection, it is the dose should be in between, dose should have the ratio of 1:2. Means if you select S1 as a 0.1 ml, that is the 10 mm, then S2 must be 14 mm, right? So S1 if it is 10 mm, then S2 must be 14 mm, and since it is giving good gradation, so you can see the S1 having the 10 mm of the height, S2 having the 14 mm of height, and there is the good gradation between S1 and S2. If that is there, then you can select S1 and S2, or you can go ahead with the 0.2 or 0.4 ml. Okay, so this is how you are going to select S1 and S2. So now since there is very good gradation in between 0.1 ml of the dose and the 0.2 ml of the dose, so 0.1 and 0.2 ml dose of the standard itself you are selecting as a S1 and S2. Now let's see how to select the test dose. So to select the test dose, you must know the response height of all the doses of the test. Okay, so let's see what is the response height here. So in case of 0.1 mm, it is giving 7 mm, 0.2 mm it is giving a 10 mm, and we know the selection criteria for test doses are they should fall in between S1 and S2. It means your T1 that you are going to select, it should be bigger than S1 and smaller than S2, and T2 that you are going to select, it should have height bigger than the S2. Got it? So very simple. So this is how it's going to fall in between S1 and S2. So now let's see what is the height of the first dose, that is the T1. So that is, it is giving you a 12 mm and 0.8 mm giving you a 16 mm. Since the your 0.4 mm of the dose, 0.4 ml of the dose, it is giving the height, response height of the 12 mm. So you call this dose as a T1, okay? And 0.8 ml of the dose, it is giving the response height of the 16 mm. Now you can see this 12 mm, it is bigger than S1, that is the 10 mm. Since it is bigger than 10 mm, so you have selected your 0.4 ml as a T1, okay? And you can see the 16 mm, it is bigger than S2. S2 height, it is 14 mm, so 16 it is bigger than 14. So you have selected T2, which should be bigger than S2. So now your selection of test dose it is done. The T1 you have selected having the height of 12 mm, which is bigger than S1, and T2 you have selected having the height of 16 mm, which is bigger than S2. Okay, so now it falls between S1 and S2. Once it is over, now you have to start giving the different doses by changing the sequence by using Latin square method. So first set that you have selected. Before that, we'll see how we have selected these doses and what doses we have selected. So S1, the dose that you have selected in case of the S1, it is called as the N1, a small N1. So it is the 0.1 ml you have selected. S2 dose that you have selected is called as N2, that is 0.2 ml. Then T1 you have selected, you can see it is the 0.4 ml, and the T2 that you have selected, it is the 0.8 ml. Okay, so that you have written in the table. Now once it is over, now you have ensured that your dose selection it is done. So in case of standard, you have selected 0.1 and 0.2 ml, and in case of the test, you have selected 0.4 and 0.8 ml. So now dose selection you are done at your end. Okay. Once it is done, now you are going to give the different doses. So let's give the first sequence, that is S1, S2, T1 and T2. So when you give the first dose, that is the S1, you get certain response. S2 you get certain response. Then you are giving the third dose, that is the T1, you got a response, and then you got a response for T2. So now once it is done, you have repeated the 4 responses, 2 of the standard and 2 of the test, now in the simple sequence of S1 and S2 and T1 and T2. Once it is over, so this is called as the set 1. Now we will be giving the doses in the another sequence which is not same as the set 1. So this sequence you have just changed here, like S1 you are giving first, then you are first giving T1 instead of the S2. Then you are giving S2 instead of the T1, and then you are giving the T2. So now there is change in the sequence. So let's give the doses with this sequence. So you have given 0.1 ml of the S1, then 0.4 ml, because the T1 is your zero point 0.4 ml. You can see here that T1 it is the 0.4 ml. So you have given the T1. Then you are giving to give the S2. So S2, how much dose you have selected? That is, in case of the standard 2, that is the 0.2 ml you have selected. So you are giving the dose of the 0.2 ml. And then you are going to give the dose of the T2. So T2 that you have selected, it is 0.8 ml. So you are going to give the 0.8 ml of the T2. So you are done with the second set. So you label it as a set 2. Okay. So till now we have done with 2 set. 2 more set we have to repeat. So in set 3 you are giving the T1, S2, T2 and S1. So T1 is your 0.4 ml of the test. So that you have given. Then your S2 you have to give, that is 0.2 ml of your standard. So that you have given. Then you have to give the T2. So the T2 is your 0.8 ml of the test. So you have given the 0.8 ml of the test. And then you are going to repeat for the S1. So S1 is your the 0.1 ml of the standard. So now you have given the 0.1 ml of the standard. So you have done with your third set. Likewise, you are going to repeat for fourth set, where you have follow the sequence of T2, S1, T1 and S2. So what is T2? So T2 it is the 0.8 ml of the test dose. So that you have given. Then S1 is your the 0.1 ml of the standard. Then T1 is your 0.4 ml of the test. And then S2 it is your 0.2 ml of the standard. Once it is done, you have done with all four set of the all four set of the doses of the standard and the test. Okay, so now your DRC part, dose response curve of the standard you have taken, then you have taken the test, you have selected 2 dose of standard, 2 dose of the test, then by using the Latin square method you have repeated the each dose for 4 times randomly with the 4 set. Okay, so after this you have to measure height of each response. Like you are going to measure the height of the 4S1. So now you can see this is 1, this is 2, this is the third S1 response, and this is the fourth S1 response. So you are going to measure the height of that particular S1. Okay, so once the height measurement it is done, then what you are going to do, you are putting that in a table. So S1 you can see there are 4 reading, like 10, 11, 11 and 10. Okay, then you can take the mean of that. The S2 you will get 4 reading. Okay, so now you can see this is one of the S2 reading. Okay, so you can measure the height of that. Okay, this is second, you can measure height of this response. Then this is the third S2 reading. Likewise, this is the 4 S2 reading. So for every response you are going to measure the height by using a scale. Okay, so you will get certain response. Likewise, you are going to measure the height for T1 and you are going to measure the height of T2, and you need to take the mean of these S1, S2, T1 and T2. Now by using the formula of 4-point bioassay, it is little bit different as compared to 3-point bioassay. You can calculate unknown concentration. Now let's see what is the formula. The formula is Ct is equal to N1 divided by T multiplied by antilog of T2 minus S2 plus T1 minus S1 divided by T2 minus T1 plus S2 minus S1 multiplied by log of N1 minus N1. N2 minus N2 divided by N1, then bracket is complete, then whole bracket is complete, that will be multiplied by Cs, that is concentration of the standard. Now we know the concentration of standard we have seen in case of the requirement, it is the 10 microgram per ml. Okay, so what this S1, S2 indicates? So S1 and S2 indicate average response height of low and high dose of the standard. Okay, so the S1 indicate the low dose of the standard, that is 10.5, it is the S1, and 14.75, that is the high dose of the standard, that indicated by the S2. What T1 and T2 indicate? It is the average response height of the low and high dose of the test. So the low dose of the test, average height you are getting 13 mm, and the high dose of the test, the average height you have getting 15.5 mm. Okay, now you can see here there was small n1 is there. So small n1 it is the dose, that is 0.1 ml of the standard that you have selected. The small n2 it is the 0.2 ml of the standard dose you have selected. Then small t, it is the smaller dose of the test that you have selected, that is 0.4 ml, and small t2, it is 0.8 ml dose that you have selected for the test. So what you need to do here, first you need to solve all these brackets. So first you are going to calculate n1 by t, then you need to calculate till here, okay. So this complete bracket you need to first solve, okay. So t1 t2 minus s2 you are taking the reading, then you are writing that here, plus t1 minus s2, that reading you are taking, okay. Then you are doing summation, and that will be divided by the summation of t2 minus t1 plus s2 minus s1. So once this particular calculation is done, then that calculation must be multiplied by log of n2 by n1. So ये calculation को आप log of n2 divided by n1 से क्या करोगे, multiply करोगे. Now you have completed this bracket. Now this complete reading whatever you will get, for that you need to take the anti-log, okay. So now you are taking anti-log of that, okay. So this anti-log will be multiplied by concentration of the standard, and whatever value you will get, that can be multiplied by n1 by t, right. And now you will get the CT, that is concentration of the test. So this is how you are going to calculate unknown concentration of the acetylcholine by using 4-point bioassay. So this is the disclaimer for today's experiment. So all data used in this experiment is for demo purpose only. It does not have any relation to the real data collected from the study of DRC of the acetylcholine. So I am correcting it. It is the DRC of the acetylcholine. All images used in this session are used under Creative Commons licenses for study purpose only. The source of images are cited wherever deemed to be necessary. So thanks for watching my session. For more such learning, subscribe to my channel, and if you like my session, then do remember to give me a thumbs up.